Welcome back. This week we're going to start talking about penetration testing. And this first week we're going to be talking about reconnaissance, both active and passive reconnaissance, and testing methodology and things of that nature. So today we're going to talk about penetration testing methodology, including PTES and OWASP. So why does methodology matter? So as it states, a penetration test without a methodology is just unauthorized hacking. You need to have this structured, detailed path of what you're doing, what you're going to be affecting, and what your scope of work is, and of that sort. So it will provide some legal protection. So if you have a defined scope, then usually, as long as you stay within that scope, you are protected against anything which happens that may be inadvertent or unexpected. If you exceed the scope of authorization, then you open yourself up to legal liabilities and potential prosecution under the Computer Fraud and Abuse Act or other laws, depending upon where this actually happens. Also, repeatability. So the methodology ensures that the tester follows the same phases in the same order so that a future tester would proceed the exact same way or be able to repeat the steps and the process. And then complete coverage. So that scope of work, the process that you end up using will have a listing of addresses that you can scan, applications that you may test, credentials you may be able to use, anything of that nature will make it so that things aren't missed. And if they are missed, well, then that wasn't in the specific scope of work, and so that's not really necessarily much of a concern. So PTES is the Penetration Testing Execution Standard, and this is an open standard which has 7 phases for a testing methodology. So it starts with a pre-engagement interaction, and this is where you sit down with the client or the business and you start defining the scope, whatever authorizations, the rules of engagements, timelines, communication, that sort of stuff. And when I mean communication, if you encounter a system which is vulnerable to a critical vulnerability or something which has a 0-day which is being actively exploited, or you encounter a system that in the process of testing ends up crashing or you discover something else about it, that's going to be who you would communicate with immediately to say, hey, this is what we did, this is what we found out, we're going to, or we can continue our testing, we may stop depending upon what you say, but we wanted to make you aware of this issue just in case something happens. So without a signed statement of work or scope of whatever you're testing, authorization, rules of engagement, you don't do anything. And usually it goes through some legal process. Frequently there may be lawyers involved just to ensure that the wording is correct and it's signed by all parties. And as long as everyone conforms to it, usually you are legally okay. In rare instances, there is discrepancies with that. There was a famous case out of, I believe it was Illinois or Ohio, where there was a signed statement of work and they had clear rules of engagement and they were executing it, and they were arrested for breaking into a county courthouse, which they were authorized to be there per the agreement they had signed. But apparently the specific section kind of had a dual jurisdiction, and the sheriff didn't like it because the person who signed the original scope went over the sheriff's head, and so it was kind of infighting there. So when I say generally, most of the times it's going to be fine, but there are some weird issues with that. Step 2 is intelligence gathering, and this is passive and active reconnaissance, where you try to actually understand the environment, understand the target, and learn more about it. So there's OSINT, which is the open source intelligence. You can do DNS enumeration, where you look at DNS records, you try to identify domains that are part of that or subdomains. IP addresses, routing, that sort of stuff. There's also employee profiling, technology stack identification. All of this intelligence gathering will happen there. And this can take some time because the passive intelligence gathering, which we'll talk about next, or in the next group of slides, that one is a lot of web searches and tools which don't touch their actual systems, but leverage various search engines and other things of that nature. Active reconnaissance is a lot more hands-on. This is where you actually try to jiggle the doorknobs and open the windows, so to speak, and you try to talk to people, and social engineering can be part of that active reconnaissance. There can be actual physical penetration testing where you test the actual doors and locks and sensors. Depending upon the scope and what you can actually do, depends upon what you'll do as part of this intelligence gathering. After that, then you have this threat modeling. And so this is where you identify likely threat actors for the target, probable attack paths. You prioritize whatever testing efforts towards realistic threat scenarios. So this is where, I mean, if you have a elevator, for instance, that's not going to be attacked by someone outside of the country typically. It's going to be attacked by someone who is local or physically there and will start trying to break into the building. Now, if that elevator is connected to the internet, then that changes who the threat actor is. If you are a large multinational business that works with the government, well, then the threat actors for that may be nation state actors. Versus if you are a small single location company, well, the threat actors for that may just be opportunistic individuals, or it could be something as like a individual that's just running some scripts against it. But typically you won't have like well-funded nation-state actors going after those smaller organizations like they would after the larger organizations. Step 4 is your vulnerability analysis. And so this is where you identify, you prioritize, you verify and validate any weaknesses which are found. And it's a mix of automated scanning and manual testing. So the automated scanning, and we'll talk a little bit about that as well this week, uses some software like Nessus to go through a lot of known vulnerabilities and start testing to say, hey, does this potentially exist as a vulnerability or not? Once it's identified, then a penetration tester typically will go in then test those actual vulnerabilities to see if they are verified or if they are false positives. And that goes into that exploitation phase. And this is where you confirm those vulnerabilities. You confirm the results from the vulnerability analysis and the intelligence gathering, and you actually do some of the exploitation. Now, notice that that is step 5, and you do all the other steps before this. You don't start exploiting anything until you understand the environment and understand the systems. The next step is your post-exploitation, where you maintain, check to see if you can maintain access, you escalate privileges, you see if you can move laterally across an environment. And again, this is all part of that scope of work and authorization. You may not be allowed to move laterally through an environment. You may just try to exploit it and then check to see if you can get in, and if so, you report that. But some environments may want you to get in and see what else you can actually see without actually changing or damage anything. And the final step, and this is the step that takes a significant amount of time depending upon how detailed and how much work you had to do, is the reporting. And this is where you will summarize everything that you've done, document all of it, provide the technical summary and executive summary, technical findings with the CVSS scores, CVE information, proof of concept evidence, screenshots, whatever you have. And this is why, if you think back way in week 1, you had to take screenshots and document things as you went along. This is where it really comes into play, is you need all of that detailed information step by step of whatever you're doing. So Pre-engagement interactions. This is the statement of work where the contract is generally drawn up. Typically, it's legally binding, where the parties have kind of a performance clause where if something is done a specific way, then they are indemnified of any penalties and things like that. And there's usually all sorts of clauses. It's a lot of legal speak a lot of times. And so if you are starting out, generally the business that you are working for will have a standardized statement of work that you will conform to. If you are doing this on your own, it's highly recommended that you speak with a lawyer ahead of time just to make sure that you are legally covered. That way, if anything happens, then you have this legal document to fall back on. The rules of engagement is going to be added to that statement of work. This will typically list IP ranges, domains, systems that you can and cannot access or test, hours that you can or cannot test, tools, techniques, and contacts, that sort of stuff. And I will reiterate that the emergency contacts and abort criteria is super, super important, because if something happens, you need to contact them. And typically they know that if you are testing between certain hours, even if, let's just say your testing hours were 10 p.m. to 6 a.m. Monday through Friday for a week, they would know that if it's 3 in the morning, you should call them if something happens. And so those emergency contacts are there to protect you and to protect the business against unexpected situations. So OWASP, this is the open source, the open web application testing. There are 12 categories for this, hundreds of test cases. It was just recently updated not that long ago, and these are the different categories. And so if you are curious, you can go looking for the OWASP testing guide, and you can look and see all of those categories and what they actually kind of encompass. So there's the information gathering. So this is where you fingerprint web framework, servers, technologies, entry points. There's the configuration testing for misconfigured HTTP headers or exposed admin interfaces. And all of this is going to be web technologies. So it is part of the penetration testing, but this OWASP focuses more on the web and connected services. Identity management, these days, everything is pretty much through an identity management. You don't have different authentication per systems. Usually you have it go through some identity management like Active Directory, or there's OAuth and other online identity management tools. And so this is user enumeration, account provisioning process, role separation. There's also authentication, authorization, there's session management, input validation, error handling. So when an application crashes, or when a web account or website gets a invalid input, how does it actually handle that? Cryptography is really important because you, as part of this testing, you check to make sure, well, does it have a proper pseudo-random number generator that is used? Is data at rest and data in transit being properly encrypted, and is it managed correctly? There's also business logic. There is some client-side part of that. And then the final one is API testing, where you're testing the API endpoints or the application programming interfaces for authentication, authorization, input validation, rate limiting, and all of that sort of stuff. So those are the 12 categories that OWASP generally manages and has for there. And again, there are lots and lots of test cases inside of each of those categories. So currently, and this was a survey that had been sent out, the top 10 concerns as of 2025. First one is broken access controls, so privilege escalation, missing function level access controls. The second most critical web application security is the server misconfiguration. So are default credentials still being used? Verbose errors, are those being turned on so that an attacker might get more information than they normally would expect? Amazon AWS buckets or other cloud buckets, are they configured correctly? Another big one is software supply chain failures. So this is becoming more and more of an issue, and I honestly expect this to stay in the top three, if not become number one at a certain point. But obsolete functions, unmaintained third-party components. Node has had a problem recently and multiple times where a package, which is being used by lots and lots of other software programs, ends up getting a supply chain compromise, and there's a vulnerable version which is uploaded to that, and suddenly now you have lots of other environments which just happen to be using that package suddenly get compromised. And so supply chain, software supply chain failures is a huge, huge problem. Cryptographic failures, so risky cryptographic algorithms, insufficient entropy, weak pseudo-random number generator, all of those are a big problem. Injection, so there's the SQL injection, there's that classic XKCD comic on little Bobby tables and things of that nature. Those are always a concern and always a problem. There's insecure design, authentication failures, software or data integrity failures, like unsigned updates, CI/CD pipeline attacks, things of that nature. Security logging and alerting failures, so making sure that audit logs exist and security logs exist, and they are being shipped off to a different system and not being maintained on the same server which has the vulnerable software. And then mishandling of exceptional conditions, so improper handling of insufficient privileges, null pointer dereferencing, which is a constant problem, as you are all probably well aware of. Not failing securely, so there's the method of where if something fails, does it fail insecurely and say drop out a lot of error messages, or does it fail securely and basically lock out the authentication? So these are the top 10 as of 2025. They'll probably change whenever the survey is done again. I probably won't go back and re-update this every year that they are updated, but if you just do a search for OWASP top 10, they will have a site with multiple versions of it going back many, many years. So when do you use each of those? So PTES is used for full scope infrastructure penetration tests. It's the entire attack life cycle, and it's used for network penetration tests, red team engagements, that sort of stuff. The scope is everything. Network, OS applications, social engineering, physical security, whatever is agreed upon in the scope of work, that's what it covers. The output is typically a detailed report. That report can be, depending upon the environment, can be anywhere from 20 to 200 pages in length, depending upon the complexity of the environment and how long it actually takes. I've seen reports which are about 30, 40 pages in length, which have lots and lots of details part of it. The engagement time really depends upon the environment. More complex environments, it could be 4 weeks, 5 weeks, who knows how long it will actually take. Simpler environments may only take about a week or so, but you're looking for a multi-week engagement. OWASP, on the other hand, is for web application security, and it's specifically related to the web's vulnerabilities and connected applications of that nature. So duration for that, again, it depends upon how complex it is and what you have to do. Could be a matter of days to weeks, depending upon the overall environment. Threat modeling and penetration testing. So again, you identify the likely attackers, the probable attack paths. So there's the STRIDE model, which is spoofing identity, tampering with data, repudiation, information disclosure, denial of service, and elevation of privilege. So you can apply that model to, and the threat categories, to whatever you're actually scanning. There's the DREAD scoring, which is the damage potential, reproducibility, exploitability, affected user, and discoverability. There's also attacker profiling. So this is where, is it a nation state actor, or is it just a disgruntled employee? Is it an insider, organized crime, just some random person on the internet? Just just kind of depends upon their motivation and the skills that they may have. And then there's also attack trees. So this will be a hierarchical diagram, which shows the possible ways to achieve an attacker goal. And so this is where documenting everything as you go through the process is really important to create those particular attack trees, and then assigning scores based off of whatever models you're actually using. Post-exploitation, so the phase, this is the end of it. So after you gain access, escalate privileges, establish persistence, et cetera, then you prove the impact. So access isn't alone is not enough. Anything you do, you take screenshots. Map whatever you can access, whatever you can see. Don't make any changes or anything, but you take screenshots of the particular exploit and what you did. You go through a cleanup process where you remove any tools, backdoors, user accounts, that sort of stuff that were created. If anything was not able to be removed, say you exploited it and then you got locked out of the system, or the system crashed in the process, document all of that and provide instructions on how to clean up the tracks of you getting into that system. And then you want to create an executive summary, which is 1 page, non-technical, kind of a very high-level overview as to what the environment looks like, how things went, what the key concerns are, and then you want to go into a technical finding of it. And that technical finding could be quite long and will include a lot of the known vulnerabilities that were found, the exploited systems, how you would end up reproducing that, and finally the remediation for that. So the remediation would be installing specific updates or blocking specific traffic based off of certain ports, or working with the IDS to add a new rule for a specific attack type. And so this is, again, the executive summary is more for the managers who don't need to know the technical details, and the technical findings are more for the security team, the ones who are actually going to be implementing all of this. And they don't really care as much about the executive summary, because that's what management and the executives really care about. And then depending upon the agreement, there may be a retest phase where, say, a couple weeks down the road, after they have implemented all of those fixes, then they may say, okay, come back and test these specific vulnerabilities, make sure that they are all secured as per the recommendations. And so what you would end up doing is you would go back and typically test those specific exploits and make sure that those systems are secured. It's not a full network wide scan anymore. It's just those specific things to be an external validator of their particular processes. So key takeaways. So methodology transforms unauthorized hacking, which is illegal, into professional, legal, and repeatable security assessment. There's the PTES, which we talked about. And those are the phases from pre-engagement through reporting. There's an OWASP testing guide for web applications and security of that nature. The pre-engagement is where you sit down with their teams and the executives and you work out what you can and cannot do. And then the post-exploitation is where you create, or where you actually prove the business impact, the lateral movement, data access, that sort of stuff. And then finally, you create a report, and that report needs to be detailed and comprehensive, and needs to be geared towards both the technical and the non-technical crowds.